When you think of the largest and most powerful objects in the universe, you may be picturing distant galaxies. Colossal nebulae, or perhaps the mind-bogglingly massive black holes that have been known to devour entire galaxies. But there is one cosmic behemoth that towers over all others, existing right at our galactic doorstep. It is not even visible with the naked eye, and yet it holds sway over the very fabric of our existence. This is Sagittarius, a star, the supermassive black hole at the heart of the Milky Way. If you want to know more about the galaxy we call home, then there is so much to explore here. With that said, let's start by taking a closer look at the black hole at our galaxy's core. Now, let's get started. Sagittarius, a star. The name might sound a bit off-putting, but believe it or not, this is actually the official designation given to the giant black hole at the center of our Milky Way galaxy. Interestingly, it was first referenced back in 1964 when Arno Penzias and Robert Wilson won the Nobel Prize for discovering the cosmic microwave background radiation, which provided evidence for the Big Bang Theory. They also noticed an unusual radio source near the constellation Sagittarius, which they labeled Sagittarius A. The discovery of this unusual object would lay dormant for several decades until a team of researchers, led by astronomer Frank K. B. Liu, confirmed that Sagittarius it was indeed a massive black hole, weighing in at around 4 million times the mass of our sun. What makes Sagittarius A such a captivating subject of study is its sheer size and power. Locates approximately 25,640 light-years away from Earth. This supermassive black hole stretches across a mind-boggling distance of 38.4 billion kilometers. To put that into perspective, if you were to somehow shrink Sagittarius A down to the size of our sun, it would still be nearly twice the width of our solar system. That's a truly staggering concept to wrap your mind around. Now, you might be wondering what exactly makes up this gigantic structure. Well, at the core of Sagittarius lies a singularity, a region of infinite density where all of the black hole's mass is concentrated. Surrounding the singularity is an event horizon, the boundary beyond which nothing, not even light, can escape its gravitational pull. This is the point of no return for any object venturing too close to the black hole. One of the most fascinating aspects of Sagittarius is the intense energy and matter that surrounds its event horizon in a region known as the accretion disk. As matter spirals into the black hole, it heats up to unimaginable temperatures, emitting powerful radiation that can be observed across the electromagnetic spectrum. The charged particles in the accretion disk generate strong magnetic fields, which in turn accelerate charged particles to nearly the speed of light, creating powerful jets that shoot out of the poles of the black hole. These jets can extend thousands of light years into space, influencing the formation of stars and other structures in the surrounding galaxy. But despite its immense size and power, Sagittarius A is surprisingly difficult to detect directly. Since it doesn't emit any light of its own, astronomers must use indirect methods to observe it. One way they accomplish this is by studying the motion of stars and gas near the galactic center. By observing how these objects move around Sagittarius, scientists can infer the presence and properties of the invisible black hole. In fact, the first direct evidence for the existence of Sagittarius A came in 1994, when a team of astronomers led by S. Andrea Ghez discovered a group of stars orbiting an invisible object at the center of the Milky Way. Further studies confirmed that these stars were gravitationally bound to a massive compact object, providing compelling evidence for the presence of a supermassive black hole. But it was until 2020 that the Event Horizon Telescope collaboration achieved the first ever image of Sagittarius, providing a visual confirmation of its existence. This groundbreaking achievement involved a global network of radio telescopes working together to create a virtual telescope the size of Earth. By combining their forces, the researchers were able to capture an image of the glowing gas and dust swirling around Sagittarius A's event horizon. Today, Sagittarius A remains an active area of research, with scientists continuing to study its behavior and impact on our galaxy. Understanding our galactic core not only helps us learn more about the evolution of galaxies, but also sheds light on the fundamental laws of physics that govern the universe, our galactic home. While Sagittarius A dominates the center of the Milky Way. It's just one piece of a vast and complex puzzle that makes up our home galaxy. The Milky Way is a barred spiral galaxy, one of many in the observable universe, each with its unique features and characteristics. The galaxy is home to hundreds of billions of stars, each accompanied by its own planetary system. And while our sun is relatively average in size and brightness, it's surrounded by 8 planets, including the only known world to support life. The Milky Way also boasts a collection of gas, dust, and dark matter that extends far beyond the visible stars. One prominent feature of our galaxy is the Orion Arm, also known as the local spur, a minor spiral arm in which our solar system resides. This relatively small arm is named after the nearby constellation Orion and is estimated to be around 10,000 light-years across. Despite its small size compared to the rest of the Milky Way, the Orion Arm plays a significant role in our understanding of the galaxy. For example, it's believed that the arm has played a crucial role in the formation of our solar system. The exact mechanism by which our sun and the planets formed within the Orion Arm is still a matter of ongoing research. But scientists believe that it all began with a giant cloud of gas and dust that collapsed under its own gravity. As the cloud collapsed, it began to spin, forming a disc-like shape with the young sun at its center. Over time, the remaining material in the disk coalesced into planets, moons, asteroids, and other smaller bodies, giving rise to the solar system we know today. However, the Orion Arm is not the only notable feature in the Milky Way. The galaxy is also home to several other spiral arms, each with its unique characteristics and star formation activity. For example, the Perseus Arm and the Sagittarius Arm are 2 prominent spiral arms located closer to the galactic center than the Orion Arm. These arms are home to a wealth of star-forming regions and are thought to have played a key role in shaping the Milky Way's overall structure. In addition to the spiral arms, the Milky Way also contains a substantial amount of interstellar material, including gas, dust, and plasma. This material is not evenly distributed throughout the galaxy, but instead tends to be concentrated in specific areas. For example, the Orion Nebula is a large, bright cloud of gas and dust located in the Orion Arm, which serves as a nursery for the formation of new stars. Similarly, the Eagle Nebula is another prominent star-forming region in the Milky Way, showcasing the dynamic range and beauty of our home galaxy. Furthermore, the Milky Way is not an isolated structure but exists in a vast network of galaxies known as the Local Group. The Local Group consists of around 50 galaxies, including the Andromeda Galaxy and the Triangulum Galaxy, which are the closest major galaxies to the Milky Way. Studying the galaxies within the Local Group provides valuable insights into the evolution and behavior of our own galaxy. By observing the Andromeda Galaxy, for example, astronomers can gain a better understanding of what the future of the Milky Way might hold, including a potential collision with the neighboring Canis Major Dwarf Galaxy. Exploring the diverse range of galaxies within the Local Group allows scientists to piece together a bigger picture of the forces that shape the Milky Way into what we see it today. While we continue to make incredible discoveries about the universe around us, there's still so much that remains unknown. From the tiniest subatomic particles to the vast expanse of intergalactic space, there is always more to discover. The pursuit of knowledge and understanding of the natural world is a never-ending journey, and we are only just getting started. As technology advances and our methods of observation improve, we can look forward to even more breathtaking discoveries that will expand our understanding of the cosmos. Who knows what wonders await us in the uncharted territories of space? Perhaps we will uncover new life forms, unearth new resources, or even find answers to the deepest mysteries of the universe. The possibilities are truly endless. So let us continue to explore, discover, and dream big. Let us marvel at the beauty and complexity of the universe and strive to understand our place within it. After all, it's not just the destination that matters, but the journey of discovery along the way.